probably new for the most part. Do you remember Venn diagrams? Do they still do Venn diagrams in the early years? So there's going to be lots of Venn diagrams, but obviously we do math, right? We will bring that into the mix. So I'll just tell you that chapter 3, which is this one, chapter 4, which is going to be counting methods. Like we're going to learn how to count like really big numbers, like how many passwords can you create if you have like 6 digits, or like we're going to do that. It's related to this. And chapter 5, which is probability, they're all connected, right? So chapter 3, 4, and 5, they're very much connected. Once we're done chapter 5, then we're going to start functions, a bunch of different functions. So it's going to change a little bit. So for now, it's gonna be newer to you. It's going to be different. You're not going to have something to draw from in the previous years. Okay, so be warned that you're going to have to probably spend a little bit of time outside of class just reviewing, refreshing, updating your study sheet, and all of that stuff. Okay, here we go. So some definitions. We will have a universal set all the time. So it's kind of like where we draw from, and we use the letter U to refer to that set. So sets usually have capital letters attached to them. And we call that universal set our sample space. Okay. So for example, let's say my universal set is the grade 12 applied class, like this section right here. Then any sets that I create have to come from this class. Okay, so let's say I create a set of students that are wearing black today. But my universal is this class. Then I can only pick from this class, all right? So universal is kind of setting a boundary as to what you can draw from. And we use a capital letter to name sets or subsets. You must use braces to open and close the set. So that is important. So braces is, so example, let's say you create a set G, then you would have a brace like that, squiggly brackets I call them, okay? And then you could have numbers in there, you could have words in there, but at some point you close it. Okay, so the braces are to start and to finish. What is a set? It's a collection of objects that have something in common or follow some particular rule, okay, which is going to be defined, or sometimes you're just going to see it. For example, what's the rule on this set? Let's see if you can figure this one out. What's the rule in that set? 2, 4, 6. There's a pattern. They're all even, right? They're all even. They go up by 2s. Yeah, but they're, even. So there's a bit of a rule you can observe. All right. You're getting it. Okay. Element. So a set has a bunch of objects in it. They have something in common, follow a particular rule. So these are objects right now. Element is the object in a set are called elements. Okay. So you can call them objects, but we also refer to them as elements. Okay. Every element must be unique. You can have no repeats. Okay. You can't have the same element listed more than once. And we want to have them arranged, either in alphabetical or numerical order. That's what we want normally. I don't think I'm going to take marks off if you don't. I'm going to check with the province. I always email the province when I'm not quite sure. I've never seen them take marks off. But the standard is to arrange it either alphabetically or numerically, okay? Subset, so this is where it changes a little bit. So you've got your set, and then you have subset. Okay, it's a set within a set. All of the objects belong to a greater set. We use the notation, it's a sideways C almost. So if you ever have this notation, A is a subset of B, that's what that is saying. So that means that all the elements in A can be found in B. This is probably one that I would suggest have it on your study sheet, because a subset, that's something they ask you about all the time. So subset, I put a star next to it, okay? In a Venn diagram, we need to change colors here. If you're asked to create a Venn diagram, subsets are drawn inside a set. Okay. If even one element in A is also part of B, then we write that they're not the same. If even one element in A is not also in B, then you would not be considered a subset. To determine the total number of possible subsets, okay, right now this is gibberish, okay, but it's 2 to the power of n minus 1. That's how many subsets can be created. I would like you to highlight that and add that. Total possible number of subsets that can be created is 2 to the power of n minus 1. For now, just have it written down. I'm going to put a star next to that one as well, where n is the number of elements in the set. N is the number of elements in the set. The set itself is also a subset. Morning. Do you have a booklet? Right here. Okay. So let's say, let's look at these two sets here, A and B. Let's check first, is A possibly a subset of B? Because it's a smaller set, right? So is blue is here, and it's also there, right? You see blue and blue? Green, 1, 2, 1, 2, right? Green is in both. And then you've got red, 1, 2, 3, 1, 2, 3. So all of the elements that are in this set are also found in this one. So we would say that A is a subset of B. All elements in A are also in B. Therefore, we can say A is a subset of B. Note, is this true? Can you go conversely and say it the other way around? Oh, let me move this up a little bit. Some of you in the back are wondering what am I writing. Can you say this? Is this accurate? No. Because not all elements in B are also found in A. Right? So watch what we do. How would we modify this? We would cross this out. Okay. Not all elements in B are in A. Okay, so how would you draw the Venn diagram? Because A is inside of, like A is a subset of B, we will do this. You create a circle, and that is B. And inside of B, you have another set. It's like a nested Venn diagram. So we want to write in what we have. So this would be blue. Should have made it a little bigger. Green and red. Okay. Because you're saying blue, green, and red is in A, and watch this, right? It's also at the same time inside of B, right? It's in both. And you need to still add the ones that aren't in A. So black and purple would go outside here. Black, purple. I apologize, it's very small, I know. Let me zoom in a little bit in case you're squinting. But this is the kicker. Don't forget this one. A Venn diagram always needs a box around it. Okay? So at the end of the day, we box this in. And that would carry the letter U. Normally, if it's not, you're not told otherwise, U is the universal set. And you could probably, what would you say the universal is right now? All possible colors, right? If you just think of colors in general, the universal is all possible colors. I can't see, I mean, A is what? Blue, green, red, are those like the primary colors that you can use to make other colors? Maybe if you had to come up with a rule, but there's no rule here. This is just as an example for you to be able to follow. Okay, so that's how you would do a Venn diagram when it's nested. Okay, watch this. Now we're gonna switch it up. So normally a set just has a letter, right? Capital X, let's say, capital A, capital B. If you have the letter N in front of it, if n of x, let's say, would be 8, if you have n of x like this, it means that the number of elements belonging to set X is 8. So we're talking about the number of elements. So if you think of the set itself, I'm going to use numbers because writing out words takes a lot. Takes more time. But you can count that there are 8 elements in X. So therefore, n of X, if you ever have the n and it's asking for how many elements are in there, you would just say 8. Okay, so slightly different way of writing it. Infinite set. The set that starts or ends with ... indicates infinite sets. So let's say set D, you have ... here. It means that this keeps going forever to the left and forever to the right. Okay. So if I ever ask you for this, you can say infinity or undefined. Do you know this notation? I'm hoping you remember that one, the infinity, right? Okay, finite set, if the number of elements is finite, it's countable, right, then it stops. So if you hear there's a 1, it starts with a 1 and it ends with a 49. What's up with the dot in the middle? You got to, in this case, what is it? 1, 3, 5, 7, 9. What would be there yet? 11, 13, right? So it's giving you a little bit of a gap, so not to write out the whole thing, but it stops at 49. Okay. I think I'm just going to stop there. Empty or null set. No elements in there, therefore it's empty. The symbol for an empty set is a 0 crossed out, or simply having 2 braces, brackets with nothing inside, therefore empty. For example, a set of odd numbers divisible by 2 is an empty set. No such number exists. Okay, so we can just say if you have an let's call it E. If you just do one of these, that's fine. Or E is 0 crossed out like that. I like the braces one. It's clearly telling me that there's nothing in there. Outliers, elements that are part of the universal, but they don't belong to any other sets that are created. This one is important as well. If you could, on your study sheet, just have them all just briefly, like just empty set is what it looks like. Maybe just have an example. Outliers, part of universal, but don't belong to any other set. I'm going to give you an example, okay? Try to add this. I know there's not a whole lot of room, but if on a Venn diagram, try to make a Venn diagram here, and you have got your universal set, and let's say you have set A, and you have numbers 1, 2, 3 in there. And you have a set B. You have numbers, let's say 5, 6 in there. and you've got 7, 8 outside there. These are your outliers out here. They're part of the universal. They're inside the box, but they don't belong to any of those circles. So these are my outliers. On a Venn diagram, they're very easy to identify. Let's keep going. I need to take my time to explain these, or else you're gonna scratch your head like, why is he using those terms? Like, I don't get it, right? So I need to make sure, take my time here. Equal sets. Sets are said to be equal if they contain the exact same elements. Okay? So so for example, let's make A the set whose members are the first 4 positive whole numbers. Yikes. Okay? So what is A? If I asked you to actually write it out, you would say 1, 2, 3, 4. The first 4 positive whole numbers. We're going to talk about whole numbers and natural numbers, all of those numbers. I'm going to give you a little diagram down the road so you know. And B, what's wrong with B right now? It's not arranged, right? But if you were to arrange it, you would clearly tell, like, oh, they're the same. They're really the same. So A is equal to B. Okay. All right, disjoint sets. Disjoint sets are 2 sets that have no elements in common. This one is important. Okay, disjoint, make sure you put a star next to this one. This is going to follow us through all the chapters. Okay, 3, 4, 5. 2 or more sets that have no elements in common are called disjoint. But in particular, make sure you have this one too. Disjoint sets are also called mutually exclusive sets. And here's an example, the classic one. Even numbers and odd numbers are disjoint. Okay, no common element can be found. So let's call E is even. Okay. So let's say we using our universal as 1 to 10. Let me back up a little bit. Sorry, guys. I'm going to call this universal. If you're universal, we're just saying numbers 1 to 10, ... 10. If I want you to write it out, please don't do the ... in between. This is just to make it a little easier. Let's call E for even. So the first, if you only consider the first 10, then it's 2, 4, 6, 8, 10, correct? Odds would be 1, 3, 5, 7, 9. Are there any common elements between the 2 sets? No. Could you say that E is a subset of O? Right? Like all of these would have to be in O. Could you say O is a subset of E? Absolutely not, right? It doesn't work. But if you ask to make a Venn diagram, you would want to start, I don't do the box until I'm done the circles. So I'm just going to take E and place them in there, and we use commas. If it's separated by commas, you're listing the elements that belong in there. Okay? So for O, you're going to go 1, 3, 5, 7, 9. And that's the set there. Now you place the box around it. That's my universal set. These are disjoint, okay? They're not overlapping. We're going to get to the point where there might be some in common, then the Venn diagrams overlap, okay? Are there any outliers that I'm supposed to add to this here? No, watch this. There are 10 numbers, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All 10 are represented in one of the groups, so no outliers there. Joint sets, 2 or more sets that have at least, okay, at least one element in common are said to be joint. Okay, so that's also important. The Venn diagram has an overlap, and it's where the shared elements are placed. So let's say A is the set of students taking grade 12 applied and taking biology 40S. Okay, there's a set of 40S and applied biology and 40S math, right? Applied. There could be students taking both. I'm just wondering, how many students are also taking biology right now? Biology right now. 1, 2, 3, 4. 4. We've got 4, 5, 6. So you got 6. So that's what I would do here. It's too many names right now, so I'm just going to use numbers to fill in. There are 6 students taking both. Okay. So this is, let's call this applied math, A, and this is biology. And what's my universal? It's this class right now. 6 students are doing both. Let's say, therefore, there might be in this room, we've got 26, 6. So let's say there's 8 only taking applied. And is there some, would there be somebody in here only taking bio? It wouldn't make sense, right? Because if you're in here, if you're only taking bio, you're not in this class right now. Okay? So, but emphasis on this. This is what I want to emphasize, that there are, in this case, there would have been 6 students that we would have put in that overlap that are taking applied math and bio at the same time. Okay? I want to add something here. Or should I leave that for later? I might leave that for a little later so that I'm not overwhelming you. Complement. Every subset has a complement. This is also very important. This is going to follow us along. I'm going to use a different color. Every set or subset has a complement. We use the little accent symbol or a little bar above it to denote that. So consider the universal set numbers 1 to 6. Even numbers are 2, 4, 6. Therefore, E with a little tick on there are all the numbers that are not in E. So what would we do here? We cross out whatever is in E. So what are you left with? 1, 3, 5. Close it. So this is even. This is not even. Say what? Isn't that odd numbers, Mr. Dirksen? Yes, we also know them as odd. But if you have that little tick there, you can also write, let's just do that next to it. E with a bar, that's what I use most often perhaps, is 1, 3, 5. Just a little, I just have a question. What would this be? If it's n of E, what does that mean again? N calls for how many elements are in E. So you go here, 1, 2, 3. That's all you'd have to do. So if the N precedes the capital, it's asking how many are in there. If it's just the capital, then I want you to write out all the elements that are actually in there. Okay? And here, this is very helpful. In general, NE plus NE not, right? So whatever is in E and whatever is not in E represents our universal set. So from this, This is the one I'm going to use most often. Actually, I will box both of these in. So if you want to know the elements, the number of elements that are not an E, you take your universal, you subtract whatever is in E, and that's how you get it. Let me bring that up a little bit here. Okay, I want to give you a little. Maybe I'll just get that in here. So I will just say that E is 2, 4, 6, and let's say that's a set. Our universal is outside here. And so in this case, whatever is not an E would have to go outside here. So it'll be 1, 3, 5. And you're like, Mr. Rickson, why didn't you make a bubble for it? Because we technically don't have a set for these numbers. These are just our outliers in this case. Okay. All right. Let's do a little bit of Venn diagramming to put this into practice here. All right. Sets can be expressed in 3 ways. Yeah. Okay, sets can be expressed in 3 ways: in words, listing the elements, or a Venn diagram, which is going to be the most popular, but you got to be comfortable with all of them. Let's assume that there's a small class of 10 students. That's our universal set. A is comprised of the following students. Notice that it's in alphabetical order. Okay, Anna, Biff. So we've got 10 students here. Let G be the students in grade 12 that are wearing glasses. That's the rule that I'm going to use for G. And I'm telling you, glasses, right? The following students are in that group. Let B be all the students with blue eyes. Okay? We've got Chip, Jenna, and Xenia. Draw the corresponding Venn diagram. Before you start, I'm going to use a highlighter for this. There's only 2 groups here. Are there any common elements between them? I see Chip and Chip, right? Jenna, right? They are in common there. Should have used a different color. I'm gonna do that here. Jenna, Jenna. So you see that there's overlap. So we know that these are joint sets. Because they have at least one element that they share. So the Venn diagram, will it overlap? Will they go over each other? Or will they be completely disconnected? They will be joined. Okay, they will be overlapping. So watch what I'm going to do here. I'm going to go with G here. Just make use of that space. And I'm going to go B over here. I'm leaving enough space in here so I can write in the names, okay? So this is G, and this is B. And what goes outside? Our universal, right? So in this case, we would go Jenna and Chip. Go in the middle. And what is left in G? What else is only in G? Are only wearing glasses? Biff, Damien, and Fernando. How many students only have blue eyes in this case? Xenia is only has blue eyes, but is not wearing glasses. Okay? So there's an overlap. We know that because there's 2 elements that they share. We just put them in one. So watch this, guys. How do you know you did this right? Cover up whatever B is for now. and just look, 1, 2, 3, 4, 5. Do you have all 5 in G right now? Yes, right? Then you cover up G, and you check, are all 3 in that other set, which we call B? Yes. And so you know that there's an overlap, but we don't write down twice. Okay, how many do I have in total? 1, 2, 3, 4, 5, 6. How many students are in this class? 10, right? Where would we put the remaining 4? Anywhere outside. They don't belong to either one of those groups that I've created, but they're still part of the class. So now it's a little bit of, how do I do this? Watch this. I'm going to cross out, I'm going to go to my universal and cross out the names I've already used. Biff has already been used, Chip, Damien, Dimitri has not been, Fernando has been, Gurjot, not yet, Jenna has been, Joel, Joel has not, right? Sorry, Joel. But Xenia has been. So we've got 1, 2, 3, 4, and that's what we expected. So just put them anywhere outside. I'm going to go Anna, Dimitri, Gurjot, and Joel. This is how you do a Venn diagram, guys. I'm gonna give you a little addition now. This is what I normally do. I go to G, and I tell myself how many elements are in G. 1, 2, 3, 4, 5. You say there are 5 in there. Then you go to B. How many are in B? 1, 2, 3. How many are in U? It's totally fine to do that. I actually prefer you putting down how many elements are you supposed to have in each one of them. Okay. Let's go true and false here. I will leave the explaining. I will leave that out. Is G a subset of A? Is G a subset of A? No, because it would have to be nested, right? All of the elements in G would have to be, oh, sorry. Mr. Dirksen, you're messing us up. This is my universal set, but what is the universal set called in this case? A, my bad. Can we change that to an A? 99% of the time it's gonna be U. But because in this case they say the universal is called A, we're gonna call this A, okay? And we're gonna put an arrow onto A saying that that's the universal. My bad. So now let's do this again. Is G a subset of A? Yes, because all of the elements in G are also part of A, so this is true. Is B a subset of A, my universal? Yes, it is true. Is G a subset of B? That is false. Okay, G is not a subset of B. Let's see if you're awake here. What would I expect to have subsets? What would I expect this to look like if there was a subset? You would expect like a nested situation, right? Where one is inside the other one, but it's not happening here. So you can expect a bunch of false here. Is B a subset of G? That's also false. Okay. There's a little bit of a glitch here. It says use proper notation to state the complement of G and B. Can we just add the B here? Get rid of the B over here. It just shifted, my bad. What's complement? What is not G? Can I help? I'm gonna help you out here. You gotta go to your universal and state everything that is not G, okay? So you take your maybe a couple fingers, cover up whatever is G, And what is left? All of these other ones are not in G. That's what the complement is. So just start stating them. Anna. What comes next? Dimitri. Then it's Gurjot, Joel, and Xenia. 1, 2, 3, 4, 5. There we go. So that's not G. I want you to now write what is not B. If I ask you to write out the complement of that, can you do that? Give it a try. Just cover up B and write out. I'm just going to cover this up for now so you can't see. You can shorten the names too if you want. So this is what I got. So I basically covered up B. And then you just list all the, technically it should be an alphabetical order. So I just make sure I count that there's seven elements that are supposed to go into this one here. Okay. Now let's answer the following. N of U. What's the universal now? It would be 10, right? What's the number of elements that are in G? What is it? 5, right? If you count. I'm trying to have both in there in the plan. Sorry, I'm going to zoom out a little bit. It says 5 in G, right? B has 3. N that are not in G, you can either count and just say 5. Okay? But here's, let's do the next one. Number of elements that are not in B, 1, 2, 3, 4, 5, 6, 7. What's that? 6, 7? Okay. Yeah, I know. Doesn't get old, does it? Can I just draw your attention to this one, though? Remember these formulas here? If you wanted to figure out the elements that are not in a particular set, you take the number of elements in the universal and take away whatever is in E. Okay? Follow me. Back to this page. Let's imagine we did not have our Venn diagram here. So N of not G would have been NU minus N of G. We know we have 10 in the universal. How many are in G? Right here. 5. So if you go 10 minus 5, you get that 5 which you were expecting. Okay. N of not B. I'm going to use bar just to mix it up because it's the same thing. You take the universal and you take away whatever is in B. So we go 10 minus how many were in B? I can look it up right here. And I get the 7. So I want you to be able to do it by observation, but I also want you to be able to use the formula, take universal minus what is in there to get that same answer. Okay? Are sets B and G joint or disjoint? B and G. They would be joint. How do you know? Venn diagram tells me so. There's an overlap. If there was no Venn diagram, how else would you have known? just by comparing them, right? They have at least one element in common. So they're joint. Share two elements. If that's how you would know. Elements. There you go. Fun stuff, eh? Not. In each case, state whether it is a finite or an infinite set, then state the number of elements if you can. Would this be what? Finite, right? No dot dots on either end. So this is finite. N of D, I should make it a bit harder, right? So you have to count at least to 20 or something. 3, let E be the set of even positive numbers. You see that dot right there? That's the dots at the end, that's infinite. So you can't really, this is not applicable. You don't know the number of elements in E. It's infinity. You can say infinite. You can have the infinite symbol, infinity symbol. I'm fine with that. They are fine with that. Okay. Now let's go to 5. I think before I do 5, I'm going to hold it a little bit on that one. I want to draw your attention to page 7. I will strongly recommend that you know what are my natural numbers, what are my whole numbers, and so forth. And I don't know, this might be too big for your study sheet, but you should know that my natural, maybe just have, I'm going to highlight what I would say at least, at the very least, you should have that. So your natural numbers are positive and they start at 1 and then they go up to infinity. What's the difference between a natural number and a whole number? The 0 is added. You see that? The 0 is the only difference between naturals and whole. Okay. I would be your integers. To be honest, like make sure, just make sure you know what you're talking about. If you don't know what I is, then you probably want to put integers next to it. Integers are positive and negative numbers, but they're whole numbers still. Okay, there's a 0, and so if you think about this 0, it starts at 0. This set, you've got all the negatives. Then you've got your real numbers. Real numbers, really anything goes, right? Real numbers, decimals, negatives, roots, anything, fractions, pi, okay? It could be rational, irrational. Why is, oh yeah, so this is supposed to say real numbers, like these two go together, by the way. And then last but not least, know your prime numbers, okay? What are prime numbers? They are divisible by 1 and itself. Those are prime numbers. So it starts with 2, then it goes 3, 5, 7, 11. Next would be 13. 6, 7 is prime. So 67. In case you didn't know. So 2, 3, 5, 7, 11, 13. The next one would be 17, 19. I would say if you have it up to there, then you're in pretty good shape. I haven't seen them go further than that. Are all prime numbers odd? There's always that one exception. 2 is always the outlier there. Other than that, they're always odd except for 2. So they try to trick you there sometimes. Okay? So study sheet, I'm just going to I would like you to just know this, but I also know that there's a lot of other stuff that we require you to know. So If you feel like you need to have a reminder, add it, okay? I wanted to make sure this is brand new for you, this page. Okay, I want you to go to 6. I would like you to try this by yourselves. So this is now a sandbox or a mud pile, and you just go in there and play and get dirty, okay? I don't really care right now if you get it wrong. Just be ready to add a correction to this later. But I want to know, like right now after hearing me just talk nonstop, can you handle this stuff, okay? Maybe I should start with, do you know what multiples of 3, do you know what that means? I'm just going to make sure you all know what that means. Multiples of 3 is you start with that number and then you go up by that number. Okay? So 3, 6, 9, 12, and so forth. What does 1 to 15 inclusive mean? What does that mean? It means 1 is included and 15 is included. So your universal is from 1 to 15. That's what that means. And then O is a set of odd numbers, so you consider 1 to 15 and create set O, list them all. T is a set of the multiples of 3, so you just include those all the way to 15, okay? And that's that, and then try to do the rest and have fun. I'll walk around if you need help. I don't know where you're at right now, but the universal, I just wrote it all out, 1 to 15. O is all the odd ones, but make sure you don't go past your 15, right? And T would be all the multiples of 3. You stop at 15 in this case. So that's what I wanted. Not O, basically, right? The best way to go about it is go to your universal and just get rid of all the elements that are R and O. So in a sense, you want to imagine getting rid of 1, 3, 5, 7, like basically all the odds. And so you're left with all the even numbers. Okay? What about not T? You want to go to universal and omit everything that is in T. So it'd be 1, 2, right? You get rid of the 3 there. 4, 5. You don't want to include the 6, right? Then it's 7, 8. You don't want to include the 9. Then it's 10, 11. You don't want to include the 12. And then it's 13, 14. Okay. So that's, and I'm just going to check something here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Got 10. T had 1, 2, 3, 4, 5. So if you think about it, 15, that's my universal, minus the 5, I should be left with 10 elements, right? So I want you to see the connection. State the number of elements in each subset. So N of O, 2, 4, 6, 8, right? Yeah. N of O is 8. N of O naught, 2, 4, 6, 7. And it makes sense, right? I would have gone universal 15 minus 8 gives you 7. N of T, what is it, 5? N of not T, it's 10, right? So, and I would like you to think NU, right, minus NT, that would be 15 minus 5, sorry. T is 5. So that gives me the 10. That's how I got this, right? That's how I got that number. So getting your complement in terms of the number of elements is just universal minus whatever is an O gives you not O in terms of elements, okay? Are O and T joint or disjoint? They're joined, right? 3, I've got 9, and I've got 15 that are their joint, they have common elements. Are all the sets always going to be joined, Mr. Dirksen? Nope. You check, right? You check. So O and T is my, I'm going to start with O here, and I know there's overlap. And this is T. I'm going to put my box around it already. That's my universal. I know that O is supposed to have 8 elements, and T is supposed to have 5. My universal has 15. That's always a good check. Okay, what are they sharing? I'm going to use my highlighter here. I'm going to zoom out a little bit so you can see how I do this. Everybody has their method, but there's 3, 9, and 15 that is being shared. Those 3 elements. So you go 3, 9, and 15 go in there like that. And then you basically look at O and just don't include the ones you already have here. So it's 1, 5, 7, 11, 13. 1, 2, 3, 4, 5, 6, 7, 8. Got 8 in there. T, I don't want to have these included, so it's just 6 and 12 really that you would put in there. And you just make sure you have the 5, right? 1, 2, 3, 4, 5. Am I done? What am I missing? I'm missing outliers, right? Correct. So make sure whatever hasn't been included, you include there. How do you do that? It's somewhat tricky. Okay, but basically, try to find out what is left. How many should be out here? Out here. Let's see. There's 8, right? 8. 9, 10. So there's still 5 elements that don't belong to either set that should be out here. And what is it? Probably the even numbers. The even numbers are out there. So you've checked that. You made sure the outliers are accounted for. This is a Venn diagram that would get full marks. Can I just warn you, down the road, there may just be one number in here, one number in there, one number in there, because that we're going to be talking about the number of elements that exist in these regions. Right now, we're actually listing all the elements, and the elements happen to be numbers. It could be names, it could be colors, what have you. Okay, create subsets of O and T. You can call them P and Q. What are we talking about? Subset, we'll do the subset of O, right? We'll just say that's what we're doing here. We're going to call that P. How do you create a subset? Whatever elements you take, they better be an O. All right, guys? They better be an O. So you've got your evens, right? No, sorry. Your odds. What am I saying? So it's 1, 3, 5, 7, 9. So how about this? Mr. Dirksen, is this a subset? Yeah, that's a subset. Or you could create P, 1, 3. Is that a subset? Yes. Or P. So don't overthink these ones. You just have to make sure whatever you use to create a subset of O, right, you make sure everything that you're putting in there is actually in O. And so this is 1, 3, 5, 7, and so forth. And there's several options that you could make. This is the tricky part. I had to email the province because there were conflicting messages. Listen carefully to this one. Is it possible to create P and list all of the elements that are in O, like basically making a copy of it? And technically that is correct. That is also correct. I will always try to do one less just to make sure I don't mess it up, but it is fine to do that. So subset of T here, We're going to call that Q. So just grab anything that is in T. So we're going to go 3, 6, 9, 12, let's say. So everything but 1 is in there. But the only thing that matters is that everything in Q is found in T. So they're subsets. So you can say Q is a subset of T. And up here, P is a subset of O. Okay, so that's also something that we've determined. What would the Venn diagram look like of T and Q? This is what it would look like. Q, let's start with Q. We would have 3, 6, 9, 12 in there. And surrounding it would be T. And the only number that I didn't use yet is 15. Okay, so that's what T would be. And then, of course, you've got your universal around all of that. Okay, that's my universal. That would be numbers 1 to 15 in this case. But if all you were drawing is the subset that you've just created, that's what it would look like. It's nested. Okay. Fun stuff, I know. I will make a note here for you. Don't, as you flip through it, don't forget outliers. Always check. Will there always be outliers? No. There could be instances where there are no outliers. Everything is taken care of one of the groups. Okay. I will assign you some homework. Okay, to try this. And I will say page, let me just go check it. I think it's page 8. Yes, page 8. So I don't know if you want to go just write it down at the bottom of 6. Homework, page 8. And the key is on page 9. So if you just flip over, the key is already there. I printed it in your booklet. So try page 8. It's going to be a little weird from time to time. We're rolling dice. It's totally fine if you draw a blank to look at the key and see, like, what is happening here? I don't understand this. It's fine. Okay, it's fine. And I just need you to wrap your head around this concept. So for tomorrow, I would say for sure update your study sheet so you know what we're talking about.